Okay, we learned that the four angles of a quadrilateral add up to 360 by doing that exercise. Okay, now, you guys, we're going to fill out the notes on this worksheet right here. Starting with quadrilateral. Okay? A quadrilateral is a polygon with four sides. Okay? It's a polygon with four sides. That's the first definition right there. Okay? You guys should have learned polygon in the past, but I think you guys might got it skipped since you guys started in secondary math 1 last year. The year before, you should have, in math 8 probably, somewhere in there, you should have learned what the definition of a polygon is. A polygon is a shape with straight sides that encloses a figure. Trista, listen, please. Okay? Okay, listen. Alexis, listen. Okay, Alex, because that's just on my mind. Alex. Okay, because a polygon has straight sides, connected segment, endpoint to endpoint, and they close a figure. So when we talk about triangles, they have straight sides, they enclose a figure, they're endpoint to endpoint. We talk about a quadrilateral, same thing. We talk about a pentagon, same thing. These are all polygons, okay? A hexagon is a polygon, and so forth. Do you guys remember those? Okay. All right, next word. Consecutive sides. Now, I want everybody on your paper to nice and neatly draw some kind of quadrilateral. Just as long as it has four sides, it doesn't matter what shape. It can be a square, it can be a rectangle. It doesn't have to be either one of those as long as it's quadrilateral of four sides, okay? Yeah. And we're going to call it A, B, C, and D. That's the name of the vertices, okay? So I am going to give you examples of consecutive sides. First of all, a little definition, okay? Sides that share a vertex. Sides that share a vertex. That's the definition of consecutive sides. Consecutive means next to. Write down. Okay, sides that share a vertex. So, for example, who can give me two sides that share a vertex up here in this example? Well, A and B are 2 points. AB is a side. What's a side that's consecutive to AB? Huh? Did someone say BC? AB is this side right here, right? BC is this side. What do they share? Vertex, B. Yeah, AB and AD would work as well. What else would work? DC, what would work with DC? BC would work. There's one more. AD and what? And BC. Those are the pairs of consecutive sides. Got it? Okay. Then we have consecutive angles. Consecutive angles. What are consecutive angles? Okay. Angles that share a side on a polygon. Angles on a polygon that share a side. For example, angle A and angle what, you guys? Consecutive means next to. So what angle is next to angle A? Angle B. What's another example? Angle A and angle what? Angle D is another example. Okay? What's another example? Angle D and angle C. And what's another example? Angle B and angle C. Angle B and angle C. Okay? Those are what we know as consecutive angles. Now, you guys, what would non-consecutive sides be? Non-consecutive. What's the definition we'd write for that? Sides that don't share a vertex or don't intersect. Yeah, you can say it either way. Just write that down. Sides that don't intersect or sides that don't share a vertex. Say that again. No. No. The side. Is AC a side? AC is not a side, is it? Okay, what's a side? Name one side. AB. AB is a side. Which one's not next to it? BC. Okay, so AB and CD are non-consecutive. AB and CD are non-consecutive. Okay, another one. What's another one? AD and what? And BC are non-consecutive, right? Non-consecutive sides. What about non-consecutive angles, you guys? Non-consecutive angles. So angle A and angle what? And angle C. What else? Angle D and angle B. They're non-consecutive angles, right? What about non-consecutive vertices? Non-consecutive vertices. Non-consecutive sides are two sides not intersecting or not next to each other. See, consecutive sides intersect, like AB and BC intersect at B, right? So non-consecutive sides are sides that don't ever intersect. Non-consecutive angles would be like A and C or B and D. So you could, yeah, that you can, well, non-consecutive angles more like angles that don't share a side. It's the opposite definition of consecutive angles, right? So non-consecutive vertices. Name me two non-consecutive vertices, you guys. A and what? C and D and B. It's kind of like non-consecutive angles, right? But you're naming the point instead. This is non-consecutive vertices right here. A and C. Okay, so what's the difference between a vertex and an angle, you guys? Okay, Lena said it right there. A vertex is a point, whereas an angle is the sides and the point, right? It's the measure in between here. So an angle is a side, a point, and a side, whereas a vertex is just the point. Got it? But when I said non-consecutive angles, angle B and angle D are non-consecutive angles, but also point B and point D, which we call vertices, are non-consecutive. Okay, and last one right here. What is a diagonal? Okay, a diagonal connects non-consecutive. It's a segment. Everybody write this down. Diagonal is a segment connecting non-consecutive vertices. Non-consecutive vertices. I don't know what you're doing. Okay, so right here, you guys, if I have E, F, G, and H right here like this, okay, according to this definition, where am I going to draw my diagonal? E to G. There's a diagonal right there. Where else? F to H. F to H. Those are called diagonals. Okay? Are there any more diagonals? What if I connect E to H? That's already called a side, right? So it's not a diagonal. Any quadrilateral only has two diagonals because you only have two pairs of opposite vertices, right? If you have a pentagon like this, all of a sudden now you have more diagonals. You have one there, one there. You have one there and one there. And you have one there. All of a sudden you got lots of diagonals, right? And the more the bigger your polygon, in other words, the more sides your polygon has, the more diagonals it's going to have. Okay? All right. Not as right now. I would like to go to that, you guys, because I think it's very valuable. But you guys are wasting my time, and you're wasting your time in here. And so if we don't have time, we won't go. If we have time, we'll go. Okay? Okay, number 7. State whether each statement is true or false. If the statement is false, explain why. Okay? Question number A. Quadrilaterals are named by listing the vertices in order. I haven't told you this yet, but the answer to that is true. Okay? True. Everybody write this quadrilateral down the side. E, F, G, and H. Write a quadrilateral called EFGH like that. We can call this quadrilateral EFGH. Or we can start with any other letter and go in any order we want. I mean, go in order, as long as we're going around it either clockwise or counterclockwise. Like I could start at H, and I could go clockwise. H, G, F, E. That's another way I can name it. It doesn't matter which letter I start with, as long as I start with one and either go clockwise or counterclockwise in order. Okay? Until I've named all the letters. Everybody got that? Everybody know how to name a polygon or a quadrilateral? Okay, part B, the segments that make up a quadrilateral intersect more than once. You guys, look, this segment is helping make up this quadrilateral. How many intersections does it have? It intersects right here and right there. So the answer to that one is false. Oh yeah, the answer to that one is true because it has two of them, right? Okay, C. The sides of a quadrilateral can also be called diagonals. What do you think? Can I call EH a diagonal, you guys? No. The sides cannot be called diagonal, so that one's false. And I'd put because it's a side. D. The sum of the measures of the angles of quadrilateral is 300 degrees. What is it? So I put no, it's 360. We just learned that by cutting out that piece of paper, right? Go to number 8. Use the diagram of quadrilateral EFGH. And I'll draw it like they have it right up here. They have it something like this. And they start E right here, F right here, G right here, and H right here. And they have a right angle mark right there. And it says, in each exercise, use the given information to find the measure. Explain how you find the measure if measure of angle E equals 70. So I write this down, you guys. I write it down inside. Measure of angle E is 70 degrees. Measure of angle F is 130 degrees. Find the measure of angle G. Well, isn't G the only one I don't know, you guys? I know this one's 90. I know this one's 70. I know this one's 130. Can I find that one? What would I do? Add them all together and subtract from 360. Everybody do that. So 130 plus 70 plus 90 makes 290 degrees. If I minus it from 360, I get 70 degrees. So this is 70 degrees. Any questions on how to find the fourth angle if you're given 3 of the quadrilateral? Okay, I'm going to erase these. Okay, what if, now the next one says, if measure of angle E equals X, so now we have an X, if measure of angle F is 124 degrees, and measure of angle G is X plus 20, find the measure of angle G again. Well, how do you find what X is? Whenever you have an X, what do you have to write? An equation. Everybody write that down. Whenever you have an X, you have to write an equation. Because we got to solve it. Chase, I think you know the answer to this already. We know what the 4 angles of quadrilateral add up to, right? And even though we're not given every angle, we're given expressions for an angle. What equation could I write? You have any clue? Well, no. X plus this angle plus this angle plus this angle plus this angle equals 360, right? So X plus what? 124 plus what? X plus 20 plus what? 90 equals 360. See, you know that the 4 angles add up to 360, right? So all you have to do is write an equation showing that those 4 angles add up to 360. Now, how do you solve an equation like this? On the left side, you have to combine like terms. Which terms are alike? X and X are alike, right? What's X plus X? 2X. What else is alike? 124, 20, and 90. Those are alike. What's 124, 20, and 90? What? 234. Okay, then what do? Subtract 234 from both sides. I get 2x equals 360 minus 234. What is that? Someone tell me. Put it in your calculator. 126. Divide that by 2, and you get what? 63 is what x is. So we go back up here. This angle is 63 degrees. And this one's 63 plus 20, which is 83 degrees, right? Because x is 63. And now I have that angle. So that's how you do those. You've got to write an equation. Okay? Go to problem number 9. To help you remember the characteristics of quadrilateral, sketch a quadrilateral. So I want you to do this right here. Make a quadrilateral. Label the vertices. What do you guys want to call it? We've already done A, B, C, D. Say that again. T. Okay, let's say we name it that. Okay, now, it says, name the sides. Name the angles, name the diagonals of the quadrilateral. So sides first. What are the sides? PA. What else? VZ. What else? TV. And AZ. Those are the sides. Okay? Name the angles. What are the angles? Just the angles. Angle T, angle A, angle V, and angle Z. There's 4 angles, right? Name the diagonals. What are the diagonals? TZ and AV. TZ and AV are the diagonals. Okay, now if it said named, here's the four sides, which of these are consecutive sides? Can you name me a pair of consecutive sides? What are consecutive sides again? No, shares the same vertex. Okay, so TA and TV. TA and TV, they share the same vertex. Consecutive sides share the same vertex. T. So consecutive angles would be angles that share the same side, right? Like angle T and angle V share this side right here, right? Angle T is this angle. Angle V is this one. They share this side. So angle T and angle V are consecutive sides. Name me non-consecutive vertices. A, V are non-consecutive vertices. What's another pair of non-consecutive vertices? T, Z. Now, if I told you guys, because your next problem, which you're going to do on your own, is going to ask you to name a pair of non-consecutive vertices and then name the diagonals. Well, they're not the same, because my non-consecutive vertices are T and Z and A and V, right? However, my diagonals are going to have the same letters in there. If I connect TZ, then it's a segment. The diagonal is a segment, TZ and AV. So this one just is asking you to name 2 points. This one's asking you to connect the 2 points to make a segment, okay? So turn it over. Your assignment is the problems on the back, okay? Plus another worksheet I have for you that's very similar to this one, okay? So get started on that one while I pass out the other one.